Okay, hello everyone. Today we start a new topic, that is induction of charge, or it's a question from NCERT also, page number 7, example 1.1. How can you charge a metal sphere positively without touching it? How can you charge a metal sphere positively charged without touching it? So this is the first figure. You choose a metal sphere, and then with respect to this metal sphere you bring a negatively charged, anything negatively charged. When you put anything negatively charged very near to that sphere, what happened? देखो, इसका जो नेगेटिव चार्ज है इसके साइड में पॉजिटिव चार्ज आ जाएगा और इसका ऑपोजिट में नेगेटिव चार्ज आ जाएगा. अब जब इसमें पॉजिटिव चार्ज आ गया, इसमें नेगेटिव चार्ज आ गया, फिगर 2. नाउ इन फिगर 3 हमने इसको एज इट इज रखा, एक साइड को पॉजिटिव रखा और दूसरा साइड को हम लोगों ने क्या किया, ये जो साइन दिख रहे हो इसका मतलब होता है अर्थिंग करना. तो जब हमने इसको अर्थिंग कर दिया तो क्या हो गया, टोटल जो नेगेटिव चार्ज है ये नेगेटिव चार्ज क्या किया, अर्थ में चला गया. ये नेगेटिव चार्ज कहाँ पे चला गया, अर्थ में. वाई? बिकॉज अर्थ इज द यूनिवर्सल एक्सेप्टर. अगर हम इसको पॉजिटिव साइड में अर्थ करता तो टोटल पॉजिटिव चार्ज अर्थ में चला जाता. मतलब अर्थ इज द यूनिवर्सल एक्सेप्टर विच कैन एक्सेप्ट पॉजिटिव चार्ज एज वेल एज नेगेटिव चार्ज. फिर हमने जब ये नेगेटिव चार्ज पूरा चला गया, पॉजिटिव चार्ज ना, फिर हमने अर्थिंग को हटा दिया. तो और फिर भी इसको अभी रखा है, इस एबोनेट रॉड को रखा है. जब इस रॉड को रखा है इधर नेगेटिव चार्ज, इधर पॉजिटिव चार्ज है. नेक्स्ट में हम लोग क्या किया, इस नेगेटिव चार्ज को हटा दिया. जब हमने इस नेगेटिव चार्ज को हटा दिया तो ये क्या हो गया, ये चार्ज डिस्ट्रीब्यूट हो गया. इस तरह से हम लोगों ने एक मेटल को विदाउट टच किए पॉजिटिव चार्ज जनरेट कर सकते हैं. ये टॉपिक बहुत ही इंपॉर्टेंट है. ये टॉपिक बहुत ही इंपॉर्टेंट है. इस टॉपिक के ऊपर बेसिस करके हम लोगों के पास इन बोर्ड एग्जाम एज वेल एज एंट्रेंस एग्जाम सो मेनी क्वेश्चंस आर कमिंग. लाइक एक मेरे पास चार्ज स्फीयर है, सपोज इसका टोटल चार्ज Q है, और मेरे पास एक और सिमिलर नेचर, एग्जैक्टली सिमिलर शेप एंड साइज, सिमिलर शेप एंड साइज क्यों ले रहे हैं, क्योंकि अगर सिमिलर नहीं लेगा एक्चुअली इसमें चार्ज का डेंसिटी डिस्ट्रीब्यूट होता है, जो हम लोग बाद में डिस्कस करेंगे. इसलिए अभी हम लोग दोनों का सेम शेप एंड साइज माना है. मानो ये 0 चार्ज है, अगर हम ये दोनों को टच करेंगे एक ईच अदर के साथ तो ये क्या करेगा, पॉजिटिव था, ये क्या करेगा, इसमें टोटल चार्ज डिस्ट्रीब्यूट कर देगा. अब टोटल चार्ज क्या हो गया, Q प्लस 0, कितना स्फीयर है, 2. सो क्या हो गया, Q/2 इन बोथ. सो नाउ दे ट्राई टू रिपेल. अब मेरे पास एक और क्वेश्चन है. इस क्वेश्चन में मेरे पास एक चार्ज स्फीयर है जिसमें Q चार्ज है और दूसरा वाला में कोई चार्ज नहीं है, Q0 है. तो अगर हम इन दोनों को आसपास में रखेंगे सो क्या होगा. यू हैव 4 ऑप्शन. ऑप्शन 1 नथिंग हैपन, ऑप्शन 2 अट्रैक्शन, ऑप्शन C और C रिपल्शन, ऑप्शन D फर्स्ट अट्रैक्शन देन रिपल्शन, ऑप्शन E फर्स्ट रिपल्शन देन अट्रैक्शन. सो लेट्स सी व्हाट हैपेंड इन दिस. ये देखो पॉजिटिव चार्ज है, ये नेगेटिव चार्ज है. बिकॉज ऑफ दैट ये साइड में नेगेटिव चार्ज जनरेट होगा और ये साइड में पॉजिटिव चार्ज जनरेट होगा. अभी भी इसमें नेट चार्ज 0 है, लेकिन अगर हम इस चार्ज का सेंटर इसको माने और इस चार्ज का सेंटर इसको माने तो ये दोनों का बीच का डिस्टेंस R1, ये दोनों का बीच का डिस्टेंस R1 है. ये Q है, ये -Q है, ये +Q है. क्लियरली R2 इज ग्रेटर देन R1. ये जो नेगेटिव चार्ज है इसका सेंटर यहाँ पे लिया है, इस पॉजिटिव चार्ज का सेंटर, इंड्यूस पॉजिटिव चार्ज का सेंटर यहाँ पे लिया है, इस चार्ज का डिस्ट्रीब्यूशन का सेंटर यहाँ पे लिया है. तो ये दोनों का बीच का डिस्टेंस R1, ये दोनों का बीच का डिस्टेंस R2. क्लियरली फ्रॉम द फिगर R2 ग्रेटर देन R1 एंड वी नो फोर्स इज इनवर्सली प्रोपोर्शनल टू R². तो इसका मतलब क्या है, ये जो पॉजिटिव चार्ज है ये नेगेटिव चार्ज है, मानो ये F1 है, इसका बीच में अट्रैक्शन होगा और ये जो पॉजिटिव चार्ज है और ये जो पॉजिटिव चार्ज है इसका बीच में रिपल्शन होगा। क्लियरली एज R2 greater than R1, F2 less than F1. So attraction is more powerful than repulsion. So overall net it will be attractive in nature. So first ये attract करेगा, जब ये attract करेगा due to attraction ये एक दूसरे का नजदीक आएगा और ये टच करेगा। जहां ये टच करेगा सो ये क्या करेगा, चार्ज को डिस्ट्रीब्यूट करेगा। एक में Q चार्ज था, एक में 0 चार्ज था, अब दोनों में Q/2 हो गया। कैसे हो गया, क्योंकि एक का चार्ज Q है, दूसरा का 0 है, by 2, that is Q/2 in both. Now as the Q/2 in both, so now both are repelling each other. So the option is first attraction, then repulsion. Okay, now in the second video, it's a very important question for board as well as for entrance exam. What happened in this question? First listen properly, okay? We have two charged particles Q and 2Q let separated by distance R. We have two charged particles Q and 2Q separated by distance R, and let F is the force between the two charged particles. Let F is the force between the two charged particles. Now you have another charged particle C, same shape and size, but the charge is 0. Same shape and size, but the charge is 0. You bring it first, connect with A, and then connect with B, and then put it again in its own position. Question is, find the new force between A and B after this. In terms of F, means you need some value, 2/3, 5/4, 7/3, whatever, you have to find out this value. This is the question. So let F is the initial force, K is a constant, Q into 2Q by R square is the initial force between the two particles. Now when you bring C with A, what happens? A and C, Q and 0, so it will distribute the charge and it will be Q/2 in both. So now after this the charge of A is Q/2. Now the charge of C is also Q/2. Now you bring and connect with B. When you bring and connect with B, now charge is distributed again between B and C, 2Q plus and this is Q/2. So what happened? 2Q plus Q/2 by 2, which is 5 Q/4. So 5Q/4. Now B and C both have the charge 5Q/4. Now again you place that C charge in its own position. So now only the charge of the B is 5Q/4. Separation is R. So according to this we can move on this. Now that C charge you place, the charge is 5Q/4 and the charge of B is 5Q/4, charge of A is Q/4. So force nu, that is K, the constant, 1/4 pi epsilon naught, Q/2, 5Q/4 4 by r square, that is 5 by 8 k q square by r square. If you compare f nu by f, what you have 5 by 8 k q square by r square by 2 k q square by r square, you can cancel it. So 5 by 16, so f nu is 5 by 16 of f. Now I give you one question for homework. Since everything is same, A is 2q, B is 3q, and the third charge, previous question it is 0, now the charge is q. First you bring and connect with A, then you bring and connect with B, and then you place it in its own position. Find the f nu in terms of old f. I can just tell you the answer. Answer is 9 by 16. Answer is 9 by 16 f, and find out it. It is your homework. Okay. Next topic is superposition of charge particle. What is superposition of charge particle? See, if more than two charge particles present, then we use the superposition theorem. What happened in this superposition theorem? If more than two charge particles present in a system, suppose you have 5 charge particles, some are positive, suppose some are negative. So you have to find net force on a charge particle. Suppose you have to find net force at 2. So we have to put, देखो जहाँ पे net force निकालना है वहाँ पे तुम्हें you have to put the pen first, and then you have to show all the force applied on that charge particle. So let's at that point 2 or charge particle 2, between these two force, the force is attractive in nature. So you will present force at 2 due to 1. Similarly, at 2 due to 3, force is attractive in nature. Force at 2 due to 3. At 2 due to 4, force is repulsive at nature. At 2 due to 5, force is attractive in nature. So now what happened? The net force at second charge particle, force at 2, force at 2 is the vector sum, force at 2 due to 1, force at 2 due to 3, force at 2 due to 4, force at 2 due to 5 का vector sum. So what is the superposition theorem? Superposition theorem is if more than two charge particles present in a system, net force applied on a charge particle is the vector sum of individual force applied on the charge particle. Individual मतलब 2 पे 1 के लिए, 2 पे 3 के लिए, 2 पे 4 के लिए, 2 पे 5 के लिए इंडिविजुअल फोर्स निकाल के उसका वेक्टर एडिशन करेंगे. देखो, this concept is very very important. Like in this question, you have 3 charge particles, 2 microcoulomb, 4 microcoulomb, and -4 microcoulomb. And question is find net force at A. So that means we have to put our pen at A. Now A and B both are similar charge, so we write force at A due to B in this direction, at A due to C in this direction. So, and this 1 meter, this angle is 60 degree, it's equilateral triangle, so this angle is 120 degree. So force at A due to B, 9 into 10 to the power 9, A and B charges 2 into 10 to the power minus 6, 4 into 10 to the power minus 6 by 1 square. 72 into 10 to the power minus 3 Newton force at A due to C, 9 into 10 to the power 9, 2 into 10 to the power minus 6, 4 into 10 to the power minus 6 by 1 square, that is 72 into 10 to the power minus 3. तुम लोग सोच रहे होंगे कि सर ने यहाँ पे माइनस साइन क्यों नहीं दिया? तो देखो, when we show the direction, जैसे positive repulsion, positive negative attraction, so A is moving towards the B. When we show the direction, we just need the magnitude, not the direction. So that's why we don't take care negative sign and positive sign. हम लोग यहाँ पे सिर्फ magnitude निकाला. अब हम लोग क्या करेंगे? From the vector addition F net at A, हमें मालूम है if two forces makes an angle या two vector makes an angle theta, then the resultant is a square plus b square plus 2ab cos theta. So what we write, force of AB square, force of AC square, 2 force of AB, force of AC cos theta, 72 divided by minus 3, we can take common 1 square, 2 into 1 into cos 120 degree, which is equals to 72 into 10 to the power minus 3, 1 plus 1 plus 2 into 1 into minus half, that is 72 into 10 to the power minus 3 into 1 Newton. अब ये आया magnitude. About direction, you can use law of parallelogram. So this one is the F net. So you can say BC या parallel to BC, you can say देखो B और C का BC का parallel में है, और you can say this is plus I coordinate, means where is the plus I. Now one question for your homework. A, B, C be a square. In each vertex you have a charge particle 4 microcoulomb, 2 microcoulomb, 4 microcoulomb and minus 3 microcoulomb. The question is find the net force at B. Means you have to find out net force at B. You have to find out net force at B. How do you find out? You have to find force at B due to A, at B due to C. Both are positive, attractive, repulsive nature. At B due to C, that is at B due to C negative. So this one is negative charge, so direction is this. So you have to find out the individual magnitude. Then you can write it in IJK form also, or you can find the resultant of this two, and then with this and this find out the magnitude and then separate it. तुम इसको और एक तरीका से कर सकते हो कि ये दोनों को IJ लेके तीनों का IJK करके कर सकते हो, या ये दोनों का रिजल्टेंट इधर दिया, इसका वैल्यू निकालो और इसका वैल्यू निकालो, दोनों का रिजल्टेंट देखो, दोनों का रिजल्टेंट में जो बड़ा होगा उस डायरेक्शन में जाएगा. ट्राई इट. हम लोग इसको नेक्स्ट क्लास में सॉल्व करेंगे. हेलो एवरीवन, टुडे we start a new type of numerical. Actually it has two parts. In the first part similar type, and in the second part opposite type. So in the first part, case 1, we deal with the similar type of charge particle. Let one is Q, another one is 2Q. Separation is B. A and B are the two positions. Okay. Two charge particle Q and 2Q separated by distance D. Similar nature means either both are positive or both are negative. What we have to find out? We have to find out the position where we place the third charge particle so that net force applied on the third charge particle is 0. So in this type of situation, if you have similar charge particle, then you must put the third charge particle, let the third charge particle is Q, you must put the third charge particle in between the two charge particles. If you put in the left hand side or in the right hand side, you get the net force are in the same direction, so net force is not 0. So to find out the net force is 0, you must put the third charge particle in between the two charge particles. So then what happened? Let the distance from the A is x and distance of the C from the B is d minus x. So what you can say, net force at C is 0. So what you can say, net force at C due to A equals to net force at C due to B. So now K is the constant, that is 1 by 4 pi epsilon naught, 2 charge Q by distance between A and C is x square. For BC, K is a constant, charge is Q by d minus x whole square. Now you can easily cancel KK, you can easily cancel this. Now don't go with the quadratic equation, it takes so much time. So how to solve it? 1 by x square equals to root 2 d minus x whole square. Now square cancel. So d minus x is equals to root 2x, d equals to x, root 2 plus 1, x equals to d by root 2 plus 1. So this is the position where the net force is 0. But at the same time, they are asking one more question. For what is the nature and magnitude of the charge particle, third charge particle, that is capital Q, in terms of small charge particle q, so that the whole system is in equilibrium. Why the nature means it can be positive, it can be negative. So if we see, if it is positive, so here net force is 0 at C due to A, at C due to B. But here this one is positive, this one is positive. At C due to A, this one is positive, this one is positive. At C, at A due to B, at A due to C. Similarly, if you put here at B due to A, at B due to C. So what we find, in these 2 points, net force is not 0 if the nature is positive. If the nature is positive. Similarly, if the nature is negative, then you get what happens if the nature is negative. This one is suppose negative and positive. So this one is attractive nature. Force at A due to C, force at B due to C, positive, negative, attractive nature. So what you find, they are opposite nature. But you don't solve in that way because it takes so much time. What is the easiest way? I can tell you the easiest way. Now I can tell you the easiest way. Don't go with that things. The easiest way is, let's suppose net force is 0 at A as well as net force is 0 at B. Now you can choose any one point and find out the net force at that point is 0. So then automatically the whole system is in equilibrium, or the charge applied on all position is 0. Let at A net force is also 0. So at A 0, that means at A due to C plus at A due to B equals to 0. So Q by x square plus Q by distance between A and B d square equals to 0. So Q x square minus Q into 2Q by d square. K cancel, Q cancel. So what you have, Q is equals to minus 2Q x square by d square. that negative sign indicates it is opposite nature with respect to the initial charge, and x, the value you get it from here, that is minus 2q d by root 2 plus 1 whole square by this square, so you can cancel it, so minus 2q by 2 plus 1, 3 plus 2 root 2 is the answer. Now we move on to the second part. Now I give you a homework. In that homework, 2q and 3q are separated by distance d, where we put the third charge particle so that the net force applied on the third charge particle is 0. Also find the magnitude and nature of the third charge particle so that the whole system is in equilibrium. Shit. Okay, so in the next part, that the last one is the case 1 and now the case 2. In the previous one we have similar nature of charge particle. Now in that one we have opposite nature of charge particle. Two charge particle q and minus 2q separated by distance d. Same we have to find out where we place the third charge particle so that the net force applied on the third charge particle is 0. Now if you have opposite nature, then your the position where you place the third charge particle is 0. It's never in between. It's either on the left side or in the right side. For that I give you a trick. The trick is that choose the position towards the small magnitude. Here, like q is the small magnitude, so you put the third charge particle towards the less magnitude, means q. Let the distance is x and that point is c, then this distance is d plus x. So now again net force at c is 0, and as we know, as here the net force is 0, so at c due to A force and at c due to B force, they are equal in magnitude, opposite in direction. So what we can write, force at c due to A equals to force at c due to B. Now k is a constant, qx square, k is a constant, q 2q by d plus x equals to 0. Now again you are thinking, why not negative sign? I repeat the same thing. Here we are not using, we are not taking the negative sign. because when we choose the magnitude, we only take the positive side. For direction, we can show it here. At C due to A, at C due to A and at C due to B, they are opposite direction. So obviously, if their magnitude are equal, then its net force is 0. So here we can not use the negative side. Q, they are cancel each other. K, they are cancel each other. Again, don't go with the quadratic equation. It takes little bit time. So we can cancel this. D plus x is root x. So x is root 2 minus 1 is dx equals to d by root 2 minus 1. So you get the position where the net force is applied on the third charge particle is 0. Now again, here they can ask you for what value of what is the nature and magnitude of the third charge particle, so that the net force applied on so that the whole system is in equilibrium. But here they don't mention it the whole system, because one is positive, one is negative. So if you say this one is negative with respect to Q, that means it is positive with respect to another one. So there is a little bit confusion. Because of that confusion, they ask you only a very clear cut thing. Means they mention you the net force with respect to A0 or with respect to B0, or they say you find the nature and magnitude of the third charge particle Q in terms of A as well as in terms of B. That means we have to find both those. For example, suppose we consider the question is that find the net force is 0 with respect to A. So if net is 0 with respect to A, suppose with respect to A is 0. Now that means force at A due to C plus force at A due to B equals to 0. I think everyone understand this. What I want to say, they mention you with respect to A or with respect to B net force is 0 when you have opposite nature of charge particle. But if you have similar nature of charge particle, then they don't, examiner don't mention you. They just say you the whole system is in equilibrium. Like here, they mention it with respect to A suppose 0. So K, A and C charges are Q into Q by x square plus K, A and B Q into minus 2Q by d square equals to 0. Here you put the negative sign because you have to find out that the third charge particle is positive or negative with respect to A. So in that's why you don't know the direction positive or negative, so you mention it with the nature. But here you not mention it with the nature because in this one you already know the direction. If it is a positive, then also it is possible. If it is negative, then also it is possible. So Q by x square, that is KQ into 2Q by d square. 1Q cancel, K cancel. So Q is plus 2x square by d square into Q. So 2x is d by root 2 minus 1 whole square by d square into Q. D cancel. So which you have 2Q by 2 minus 2, 3 minus 2 root 2. And this sign positive means with respect to A, the nature is positive. With respect to A, the nature is positive. Now I give you one homework. In homework you have same two charge particle 2Q and minus 3Q separated by distance d. Their opposite nature. Find where we place the third charge particle so that the net force applied on the third charge particle is 0. Obviously you put on the left side because it's a smaller nature. And by putting this you have to find out the position is this one and the for this one is net force at A is 0. So if you consider net force at A is 0 and then you have to find out the third charge particle in terms of the small q, means capital Q in terms of small q is, this is the magnitude. Try it. Okay, thank you.